Hi everyone, thanks for looking at the video. Today we're going to be looking at positive and negative numbers, but instead of using a number line, we're going to be using a different method, which is integer chips. So looking at the do now, we're asked the temperature at your home in the Bronx is 60 degrees Fahrenheit. Take a trip to the North Pole where it is negative 50 degrees Fahrenheit. How many degrees was the temperature change? So, if we were to set up a basic number line with 0 in the middle, 60 on the right side, and negative 50 somewhere down on the left, if we're starting at positive 60, going all the way to 0, and then going to negative 50, let's see how many degrees that is. Well, from here to 0 is 60, and from 0 to negative 50 is 50. So what's the total distance from here all the way to here? Well, 60 and 50 together make 110. So the temperature change was 110 degrees Fahrenheit. So in class we looked at a picture, and some students were able to recognize that this time of the year was Black Friday. And as you guys know, during Black Friday there are tons of sales. People go nuts. They're always running out, buying, trying to get the best deals on clothing, electronics, all sorts of things. And we discussed why it's called Black Friday. Well, it happens on a Friday, so that's the Friday part, but why is it called Black Friday? So let's take a look. It comes down to accounting and the way numbers used to be, and in some regards still are recorded. So if we have two companies, Company A, this one brought in $12 million, but they spent $10.5 million in operating, so that could be electrical, rent for their stores, or offices to pay their employees. So that leaves them with a net of $1.5 million. That's how much money they've made. That's what they brought in, that's what they spent, that's how much they've made. Company B, however, brought in $18 million, spent $22. So they've spent more than they have. Their net is $4 million, but it's in red, and that represents negative $4 million. That means they're in debt $4 million. So Black Friday got its name because stores up until that point in the year, a lot of them had been operating in debt until their revenue from all the sales from shopping increased and was more than the expenses. So they were out of debt, into the black, and that's where it gets its name, Black Friday. Okay, Tate owes his sister $6 for helping him mow the lawn. He earns $4 for delivering paper, which needs to be used to pay back his sister. Is Tate in the red or is Tate in the black? Explain. Well, we have a little diagram we can look at. Julia represented this situation with a chipboard. 6 red integer chips, 4 black integer chips. This is the money Tate owes, the money Tate made. Using her chipboard, she decides that Tate is in the red by $2. How? Well, if we compare, we see that there are 6 negatives, or 6 red chips, and 4 positives, or 4 black chips. There are an extra 2 red, so that represents the $2 that he ends up owing his sister. Oops. This idea is a zero pair. We have the 6 negatives and the 4 positives, and these ones right here are going to cancel each other out, leaving just the 2, because think about it, a positive and a negative really cancel each other out. I have $1, I lose $1, cancels each other out. I get a pencil, I lose a pencil, cancels each other out. So all these cancel each other out, leaving these ones which have nothing to cancel out, and that's what's left over. So that would represent 2 negatives. Let's try the same thing for all these problems. We have 4 plus negative 8. If If we bring out 4 positives, and we bring out 8 negatives, I'm just going to use some shortcut. Can we make some 0 pairs? Sure. Well, this positive and that negative cancel each other out, cancel each other out, cancel each other out, cancel each other out, and we are left with negative 4. If we do the same thing over here, let's see, 2 positives, and I'm just going to borrow these ones from before. Let's try something else. Nope. Okay, these ones are going to cancel each other out, or 0 out, 0 pair, 0 pair, and we're left over with 7 negatives. Now you should start to notice, we started with more negatives here, so our answer was negative. We started with more negatives here, our answer was negative. Maybe we're starting to see a pattern. Take a look at this one, 6 negatives plus 12 positives. What? 0 pairs? What's left over? Well, 6 positives are left over. Hey, our pattern's starting to hold true. We had started with more positives. We have more positives left over, so that's our answer. Let's take a look. Negative 13 plus 6. Using a chipboard, cancel all those out. What's left over? 1, 2, 3, 4, 5. Negative 5. How about here? If we haul out another chipboard. 1, 2, 3, 4. Negative 4. 14 plus negative 10 is negative 4. This one's a little bit different. We have 2 negatives. Negative 6 plus negative 4. What do you think is going to happen? Well, I have 6 negatives and 4 negatives. Do we have any 0 pairs? No, we don't. Nothing can cancel out. All we're left with is negative 10 overall. Okay. So we have some situations. We're given this chipboard and that's all we know, right? It's got 8 positives and it's got 12 negatives. Original chipboard. So what is this situation? Well, I have 8 positives and I have 12 negatives, and I'm going to put these in parentheses. Some people have been asking about why we use parentheses around negative numbers, because whenever we have 2 signs, like a plus and a minus right next to each other, we like to use parentheses to break it up to show that we're working with a negative number. So we get 8 plus negative 12 equals, if I was to make 0 pairs, 8 of these would cancel out with 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. What's left? 4. But there's more negatives than positives, so that's negative 4. Okay. Yep. I had a feeling that was going to happen. Okay. Add 5 black chips. If I add some black chips here, what's going to end up happening? 1, 2, 3, 4, 5. Now I can make my 0 pairs, see what happens. Okay, that's the idea behind these problems. I'll leave the rest up to you. Give 3 combinations of red and black chips. So I'm looking for combinations that will make 0. Basically, whenever I have the same amount of black and red chips, I'm going to get a combination of 0. So anything, we could say 5 red chips, 5 black chips. That would make 0. They'd cancel each other out. 10 red chips, 10 black chips. I think someone today said 1,000,000 red chips, 1,000,000 black chips. Yep, that would make 0. Number 12, we're trying to make a combination. Number 2, we're trying to make a combination that would make positive 12. So again, we're looking for a situation where we're going to wind up with 12 more black chips than red chips. So whatever numbers we pick, we want the black chips to be 12 more than the red chips. So we could say, just as a very basic problem, 1 red chip and 12 more than that would be 13 black chips. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These two would cancel each other out, and we'd have positive 12. Okay? And again, anything like that. Same here. We're trying to make a combination that would make negative 7, so that means we need to have 7 red chips more than whatever our black chips are. So we have, I don't know, let's say 3 black chips. How many red chips do we need? We need these ones to cancel out and to have 7 left over negative. So we need 1, 2, 3. Those will all cancel each other out, or 0 out with 0 pairs, and then 7 more. 1, 2, 3, 4, 5, 6. All right, 125, same deal. We need to pick numbers where there are 125 more red than black. This table is a little difficult. People had some questions on it. Starting with red chips, 3 of them, and we we add 5. So if I was to just draw this in over here, 1, 2, 3, 4, 5. These would 0 out, and we're left over with 2, so we'd wind up with 2. So our statement would be the 3 red chips, negative 3, add 5 plus 5 equals 2. Okay, here we go. Tricky. This one said, number 2 says to subtract 3 red chips. I don't have 3 red chips. What can we do in order to handle that? Well, I can put a red chip here so that I have 3 to take away. However, when I just put a red chip there, I've changed the starting value. So the only way I could put a red chip there without changing the starting value is to put it as a 0 pair, right? I put this red and black chip together down, but together they make 0, like nothing. It's kind of as if I've added 0 to the problem in the form of a red and black chip. Now I have something that I can take away, right? I have 3 that can be subtracted. So we subtract those 3. What are we left with? 1, 2 black chips, 2 positives. And the sentence we can write is, let's see, we had 2 red, we started with 2 red and a black. Well, together that makes negative 1. And then we subtracted 3 red, so we subtracted 3 red, and that gives us positive 2 again. Okay, number 3, we had 6 negatives, something happened, we wound up with 2 positives. So some people over here said subtract 3 red. That would be totally acceptable. Some other people said that's not the only thing. Whoops, typo, 4 red. If I put 4 black here, I'd make 4 0 pairs. So we could have said add 4 black also. 2 different ways to think about that. So our statement, I'm going to type this one out, could be negative 6 minus negative 4. Wow. Wow. Equals negative 2. Or we could have said -6, same thing as before. +4 equals -2. So same idea, taking two different roads to get there. Okay? Number 4, we started with something, we subtracted 3 reds, we wound up with 4 black. I'll leave you to think about this one. Thanks for turning on the video. Keep checking them out every now and then just to review what things that we learned, things that we did in class. And if you have any questions, please feel free to message me or stop by during lunch, before or after school. Thank you.